Okay, I have an example here of finding the greatest common factor. First of all, when you look at an expression, before you find the greatest common factor, you need to figure out how many parts does the expression have. And you determine that by looking for plus and minus signs between the terms. Or how many terms does it have? There's a plus sign, and there's another one. So this expression, how many terms do you think you see there? Hopefully you said 3. Here's one term, here's another term, and here's the last term. So there are 3 terms. So when you're finding the greatest common factor, you look at each term and see if they have a common number that they all can be divided by. So, this has a 6. Can I divide 6 into that? Nope, it's too small. Can I divide 6 into that? All right, what are some other numbers that divide into 6? 2. 2 goes into 6. Does 2 go into 3? Not evenly. And when you're doing a greatest common factor, you need to be able to find something that divides evenly into all 3. And you're probably thinking, I'm being kind of silly because I should notice that they all divide by 3. And you're right. So one of the factors that's common to all of those is a 3. Is 3 the greatest in terms of numbers? Yeah, because we tried 6 and 6 didn't go into the others. So 3 is good in terms of the numbers. Now we have to look at the variables. This has an x squared, this has an x, and this has an x to the third. Can I divide x to the third into all of them? No, because this one doesn't have x to the third. So in terms of x's, what do you think the greatest x is that could divide into all 3 of them? It's going to divide into all 3 of them. Hopefully, you said x. And what about y? Well, this is a y squared. This is a y to the third, which is y squared times y. And this is a y squared. So y squared becomes a common factor. All right, what about m? This is an m squared. Ooh, this is an m squared. That guy doesn't have an m. So I can't use m because we want greatest common factor. So I think I have it here. Now, so the greatest common factor is 3x squared y. Now, I can also look at this expression and ask you to factor the expression. If I ask you to find the greatest common factor, that's the answer. If I say to factor it, then I want you to write down the greatest common factor and then factor that out of the expression and write what's left inside the parenthesis. So, once you determine the greatest common factor, write it underneath each part, 3xy squared. 3xy squared, 3xy squared. And then reduce each part of the fraction, and the reduced answers are going to go inside of here. Now notice there's plus signs there and there. So I'm going to have 3 answers in here. If I start with 3 terms, I'm going to have 3 terms inside. So 3 goes into 6, 2. This x, all right, so 3 cancels in there, 2. This x cancels with this, leaves an x. This y squared cancels with that completely, and I have an m squared. All right, let's do the same thing here. If you think you know how to do this, stop the video and finish it, and then turn on the video and see if you get it right. All right, here we go. 3 crosses out. The x crosses out. Y squared can cross 2 of these out, leaves a y, and the m squared. So what have I got left? Y m squared. All right, let's do this last part. 3 is gone. I can do an x from there, leaves x squared. And I can take 2 y's and 2 y's there. So on this part, I've just got an x squared. And there is the factored answer. So when you have an expression, I can ask you, what's the greatest common factor? You only have to give me that. If I tell you to factor, then I want the greatest common factor and then a parenthesis with the new reduced expression inside the parenthesis. I think you could do some of these. Good luck. All right, here's another one. find the greatest common factor, and then we're also going to factor. Okay, so we're going to do two things here. All right, so I need a number that divides into both 8 and 12. Well, 2 goes into 8, 2 goes into 12. Could I find a bigger one, though? Well, 8 goes into 8. Does 8 go into 12? No. So 8's too big. How about 4? 4 goes into 8 twice. Does 4 go into 12? Yes. All right, so let's use 4. So that means 4 in terms of the coefficient. Now, let's look at the z. I have a z to the 4th and a z to the 3rd. When things have exponents, as long as all the parts have that variable, you can use it. But use the lowest power, because I can take 3 z's from here and I can take 3 z's from here. But I can't use z to the 4th because that one doesn't have 4 z's for me to take when I'm doing a greatest common factor. All right, so now on the m, am I going to put m squared or m to the 4th? I hope you said m squared. You always take the lower of the common ones. All right, let's look at the p's. Do I take p or p squared? I take p. There's the greatest common factor. So, now if I want to write it in factored form, I do 4z third m squared p. Then I put a parenthesis over here. There's 2 parts with a minus sign between them. To figure out what goes in each part, I take my greatest common factor and I put it underneath each part, and then I reduce. Careful that you copy it correctly, because if you don't copy it right, you could make a mistake. All right, so 4 goes into 8 twice. Z, take 3 z's here, take 3 from here, leaves a z. Take the m squared, take the p. So I'm left here with 2z. All right, see if you can figure out the next part before I do. Stop the video, check it out. 4 goes into 12. 3. Both of those. 2 of these leaves m squared. 1 of these, p. So 3 m squared p. All right, that's the greatest common factor, and this is the answer in factored form. I bet you can do these on the homework. Good luck on lesson 33.